Hey everybody, welcome to your first real lesson in 30-2. The last lesson was review. This lesson we get into our first unit, which is all about rational expressions and rational equations. Now, I want you to remember that you've been working with rational numbers for a long time. In fact, since elementary school. A rational number is nothing more than a fraction. So before we start looking at fractions in grade 12, what I want to do in each lesson is I want to go back and talk about fractions from elementary school. So let's take a look at a couple of fractions right here, 4/8 and 12/24. If you had to describe these fractions, what would you say about them? Well, what I can notice right off the bat is that these are actually the same thing. They're equivalent. They just look different, but they're the same thing. They're equivalent. What is another equivalent fraction to the pair above? Okay, well, a lot of people right off the bat say, hey, if I look at 4/8, I know I can simplify that down to a half because I divided numerator and denominator both by the same thing, by 4. I could also, instead of dividing, I could multiply by the same amount. I could multiply both by 2, top and bottom by 2. So 24/48. So how could we find any equivalent fraction then? Well, I'm going to write something weird here. Well, not weird yet. Okay, I'm going to say I can multiply numerator and denominator. I'm just going to write top and bottom, but numerator and denominator, multiply or divide top and bottom by the same number, by the same amount. Okay, I said I was going to say something weird there. I didn't there. I said multiply top or bottom by the same number. This isn't weird, but this is what I really want you to think that we're doing. I'm just going to erase that. What you're going to hear me say for the rest of the unit is this. We're actually going to multiply top and bottom, the whole fraction. We're really going to multiply this by 1. What? What's he talking about? Okay, let's go back up here to 12/24. And I said, listen, I could have multiplied this top and bottom by 2. Well, what I really want you to think about is when we do that, when we multiply numerator and denominator by the same thing, what we're doing is multiplying by 1, because what's 2/2? 2 divided by 2 is 1. This is 1. This whole thing is 1. So what we're doing when we're multiplying or dividing by anything, so yeah, I could change this to division like that. I want you to think that we're really multiplying or dividing by 1. The reason why I'm saying that is that's the only number we can multiply or divide by that doesn't change the value of something. As soon as I say I'm going to multiply it by 2, I'm changing the value. I can't change the values of these things. I can only change how it looks, right? So I can go to my bank and say, change my money to American, and they'll do it because it's the same thing, just in a different form. I can say, change it back to Canadian. They'll be like, okay, that's weird, but we can do that because it's the same thing. I cannot go into the bank and say, hey, multiply my money by 2. I can try, they're going to toss me out. Okay, so what I want you to think about is we're changing the way these things look, not what they're equal to. And how we do that is by multiplying or dividing by 1 in a sneaky way. Now, this is stuff, the first 3 questions that I could have done in elementary school. And I could also use my calculator. Here we go in grade 12. In grade 12, we're going to start having variables. So remember, a variable is a number It's any number, we just don't know what the number is. The same rules of elementary school apply in grade 12. So if I wanted to find an equivalent expression to this, well, I could divide both numerator and denominator by 3, and I could have that. Or, I don't know, I could multiply numerator and denominator by 2, and I would get that. Or I'm going to go crazy here. I'm going to multiply the numerator by x squared minus 1, and the denominator by, of course, the same thing. This is what we're going to start looking at in this unit. And do you see the difference of squares there? Stuff that factors, just like our first little mini lesson of review. So we're going to start looking at more complicated fractions. What I really just need you to think about is all the rules I learned in elementary school are the same here. And at one point before you had a calculator, you knew these rules. So we just need to practice them. To create any equivalent rational expression, we multiply or divide both the numerator and the denominator. I'm just going to say top and bottom by the same amount. This amount could be any number or a variable. Now, really, a variable is a number. I want you to think that. We just don't know what that number is. Determine an equivalent rational expression for 4x squared plus 8x divided by 4x. Okay. So by multiplying. So remember, I'm really going to multiply by 1 in a sneaky way. So I'm going to multiply numerator and denominator by, I don't know, 2, keep it simple, right? And that would be 8x squared plus 16x over 8x. Now here, I could have multiplied by an infinite number of things. Agreed? You could have thought of something very different. But now let's look at B. It says, let's factor then divide. Okay. So what I'm going to do is I'm going to say, hey, what can I factor to there? There's a greatest common factor of 4x. And now I can divide. 4x divided by 4x is 1. And I'm left with x plus 2. Let's think of these two answers here, or maybe these two questions. Part A, how many answers could there possibly be? Part B, how many answers could there possibly be? Part A, if I'm saying multiply and every person in the class could choose a different number, guess what? An infinite amount of answers. Part B, one answer. Factor then divide. There is one answer here. So guess what your teacher is going to ask you to do? B. Almost every time, B. And you'll also see why when we start getting into some deeper questions. So factoring is going to be your friend as we go through this unit. For each of the following, determine if the rational expressions are equivalent. So again, if they're equivalent, it means I've multiplied or divided numerator and denominator by the same thing. So I'm going to look at this. I'm going to say, okay, to go from -9 to -18, they multiplied by, whoever did this, by -2. So now I'm going to go down here. I'm going to say, okay, if I multiplied 3x by -2, that would give me -6x. That's good. And if I multiply -1 by -2, I get 2. Bingo, they're equivalent. I go to the next one. I say to myself, okay, maybe I'll go this way. Doesn't matter the order I'm doing this. I'm going to say, someone multiplied this by 2. So if I go up to my numerator, x times 2 would be positive 2x. They've got -2x. These are not equivalent fractions. Now, I'll show you a little handy thing here on our calculator. So I'm going to go find my TI calculator, which I will have to grab in just a second. So hold on. Okay, of course, when I go to find my TI emulator, it stops working. what else would you expect in the middle of a presentation? I'll make a second little video to follow this one when I get it working, and that will show you a little helpful trick that you can use on your calculator to see if these things are equivalent. Okay, so I'll do that in the next video. Okay, let's continue on then. Next page. So what we've got here is what we want to start thinking about is when we're dividing by fractions, when we've got, I should say, dividing by numbers, what we want to think about is there's one number that we can never, ever divide by. That's 0. It doesn't make sense to divide by 0. If you want to think of division as breaking things up into pieces, if I said I had a chocolate bar and I want to break it up into 0 pieces, that really doesn't make sense. I can't do it. Okay, if I have a physical object, I can't break it up into 0 of something. So that's why we can't divide by 0. For us, why this is going to be a problem is now that we've got variables in the denominator, we need to be careful that we're not dividing by 0. So we have to find the values in the denominator that make it equal to 0. We will call this the non-permissible values. Or when we're being lazy, NPVs. And I'm lazy, so I'm going to say NPV a lot. This is incredibly important. I cannot stress enough how important this is going to be for this entire unit. So if you struggle with this, I need you to come to tutorials and ask some questions right away. So state the non-permissible values for each of the following. Okay, so I don't care about the numerator. I only care about the denominator. I do not care about the numerator. I don't care if the top is 0. I only care if the bottom is 0. So I say to myself, what makes 7x equal to 0? So I make a little mini equation. Okay. Isolate for x, I'm going to divide both sides by 7. I'm going to say x can't be 0. So I'm just going to add in, I don't want this to be 0. X can't equal 0. Done. Next one. Again, I only care about the denominator, not the numerator. All I do is I make a little mini equation, just like that, and I isolate for x. X can't be 7. Okay. Done. Next one. X can't be 0. Isolate, so I'm going to add 1 to both sides, and I'm going to divide by 3. There it is. Okay, do you notice on B and C, x can actually be 0? A lot of students struggle with this at first. They immediately always say x can't be 0, which is very wrong. If I go and check my work here, if I let x be 0 right here, I'm going to get 0 minus 7. I'm going to get minus 7 in my denominator. I'm allowed to have a denominator of negative 7. So the answer isn't always 0. I need you to think of that. Okay, a few more. D. Well, D, it says 3x squared. And there's a squared flying around. Is that squared going to affect how we're doing our work here? Well, I don't know. Let's make a little mini equation. Divide both sides by 3. Square root both sides. X can't equal 0. Did the square root really change how we did the question? Not at all. Okay, E and F. These are my ones where I'm going to put a big star beside it. Bang, bang. Why? Because now look at this. X squared minus x. What I need to do here is factor. This is one of those reasons why we practiced this so much yesterday. We need to factor. Now, what I say to myself is x can't equal 0. can't equal 1. The two things that make those individual parts equal to 0. That was how we ended yesterday's lesson, if you remember that. Okay, x squared minus 1 can't equal 0. So I factor it. This is a difference of squares. So there's my conjugates. So x can't equal 1 or negative 1. And I would write that maybe like that instead. There it is. So those are called the non-permissible values, the values that make our denominator equal to 0. Now, a better question to see if you really understand this is asking you to work backwards. I tell you the non-permissible values. I say, hey, the non-permissible values are this and this. So if I want to work backwards from this, I'm reverse engineering this. Think that the person that did this had an equation to begin with. They're saying that's got to be x plus 2 can't equal 0. And this one here is x can't equal 0. So guess what? Here's our non-permissible values. X plus 2 and x, those are the things that give us our non-permissible values, I should say. And I put those in the denominator. And do I care about what's in the top, the numerator? No care, don't care. I don't care what's up there. You put whatever you want up there. There it is. So when I get this slightly deeper level question, what I'm doing is I'm undoing my work. I'm making a little mini equation. X equals to 1/2 is a slight touch more difficult. So what I'm going to do here is I'm going to multiply both sides by 2. So I'm going to get 2x is equal to 1, and then I'm going to subtract 1. So that can't equal 0. So here goes my rational expression. X minus 7, 2x minus 1, and again, I don't really care what's in that numerator there. Now, before we go on to the summary, I just want to talk about this last one more time. This is really wrong. I'll do it in bright red. Do not tell me, don't do this. No bueno. Wrong. Don't write it like this. We'll never write our factors with fractions. We always want them to be integers. So this is how I want to see it. 2x minus 1. Not this. This will not be good. Okay. So, summary. Things I should know from today. Rational expressions are nothing more than fractions, but now we've just got some variables flying around. We can find equivalent fractions by multiplying the numerator or denominator by the same amount. So really I'm multiplying by 1 in a sneaky way. When polynomials are involved, hey, we might have to factor first, probably every question. And since division by 0 is not defined, we have to find the values that make the denominator equal to 0. We will always find these in every question. So if you're having a problem understanding non-permissible values after you're done your practice, you have to start asking questions right away. It is very, very important. Okay, there it is, my friends. Like I said, I'll post the second video right behind this one that'll show you how to maybe check some things in your calculator. Otherwise, have fun with your practice. Let me know if you got questions.